Hi everyone, this is David LeMay, a mentor of Team 247, and what you're seeing is a video that I'm prepared for my team, but it will it'll be useful for any team that's part of FRC Robotics. I want to talk today about joysticks. So, there's a lot of errors that can happen with joysticks, and it's really important, especially for the drivers and possibly for the pit crew, to understand how these happen. If your team is like mine, a lot of times they call for a programmer anytime that the joystick isn't doing what they want it to do. And so we want to make sure that everyone involved knows how to use the joysticks at the driver station. I'll be doing some other videos on other aspects of the driver station. This one is just related to joysticks. All right, so the first thing to do is know where to find the joystick controls. So, first of all, you'll notice this. This is the driver station. This is 2021 version driver station, so whatever we use in 2022 will be likely different than this. But this part has been very, very stable, and everything I'm going to show you today has been stable for years, so it would basically look the same no matter when you what version you used, or it'll be very, very similar. So the first thing is, you can tell if your joystick is connected if this light is green. Doesn't matter, right now I'm not connected to any robot, so I've got no communications, I've got no robot code, but it knows the joysticks are there. If I pull it out, joystick's not there. You want that one to be green if you're actually planning on using the robot. Plug it in, wait for a second, it goes green. Now, to find out where your joystick configuration is, or to change it, you look over here on the left-hand side. This left-hand side has all sorts of goodies about what you can learn about your robot. Most people just stick to the home page and they leave the programmers to the other ones, but actually there's a lot of useful information here. You can find out stuff about your robot, whether it's really talking, you can change some of the settings, and you can do the subject of this video, which is the joysticks. So, take a look here. This will tell you what joysticks have been connected. When I say have been connected, what I mean is, at one point there was a Logitech Attack 3 joystick connected to this driver station, but it's not there right now. The ones in bright green are the ones that are currently connected right now. If you want to see whether the controls on any given joystick is working, or if you're a programmer who needs to program these things, make sure that that one is selected. Right now, joystick number 1 is selected, which isn't connected. There's nothing in joystick port number 1, but joystick port number 3 is the Logitech Extreme 3D, and I've got one. If I had my camera on, you could see it. It shows you the axes. Axes are anything on the joystick that can be used to do a wide analog input. That's the directions that you can push on the joystick, but it might also be there might be other things. For example, on the Logitech Extreme 3D, there is a switch that you can move up and down, and it'll show you the direction of motion of that particular device. You can't see it, but I'm just moving a switch up and down. We've sometimes used that for throttle inputs in the past. The x-axis is left and right. The y-axis is forward and back. The interesting thing that's a little bit counterintuitive is that when I want to increase the value of my y-axis, I pull the joystick back. That feels like, if you were to look at a graph on a regular graph paper, the XY convention is that forward would be plus Y. But on a joystick, backward is plus Y. One thing I should note is in the middle here, that's always value 0. So these are all at 0 right now. I'm not holding the joystick. If I push the joystick forward, my y-axis goes down all the way to -1. Joysticks are always calibrated so that the most extreme is 1 and the most extreme negative is -1. If I pull it back, it goes to +1. Now, why is this? Why did they do it in what seems backwards? Well, the reason they did it is because these were originally used for flight, and pulling back means go up, which seems like positive. In software, what we will do is make sure that when you push the joystick forward, the robot goes forward. We will invert the joystick entry so that you can drive intuitively. The other thing that this joystick has, that not every joystick has, is a rotation feature. I am currently twisting the stick, and I can use that to go left or right. Most of the time, we run tank drive robots, which means the left side and the right side act independently. Each one has their own joystick. We only use the y-axis, and when we want to rotate, we pull one axis forward and one axis backwards. That'll cause the robot to rotate. It's called a differential drive robot, and when you have them going in two different directions, you will cause the robot to turn. However, you can do it with a single joystick if you've got a rotation axis, and we have used some of those in our previous competitions where we wanted, especially with mechanism drive, you might want to do independent forward and back movement and rotation at the same time. So we've done it a variety of different ways. We can do it a variety of different ways. One of the things that's very important about joysticks is this USB order. It must always be consistent. When the software teams writes programs, they will typically put the left tank drive joystick in position 0. The software will look for something in position 0. So you have to make sure, if you expected the Logitech Extreme 3D to be in position 0 and it ends up in position 3, that's a real problem. But on this screen, you can move it. You can set it. Now Logitech Extreme 3D is in position 0. If you always plug it in exactly the same order, you will always get the same results. But once you change that order, all bets are off. That can suddenly be a different one, a different place. So just because you're plugging it into the same port doesn't necessarily mean it will show up in the same number. It will if you do exactly the same thing, exactly the same way, but once you change it at all, you can't count on anything. That's the reason that we, in our driver station, always have all of our joysticks connected to a single hub, and the single hub is then connected to a single USB port, and we always plug in that. We never unplug the joysticks from the hub, and we plug in one USB connection with the hub. That keeps everything consistent, and that way we are sure that we actually are using the joystick that we need. Nevertheless, drivers should always check this in the pits. Make sure as you get ready to go, and if you have an opportunity as you set up the driver station, make sure that everything is in the right port. Otherwise, when you plug in the robot, if you were expecting it in position 1 and it ends up in position 0, or vice versa, right now I'm showing it in position 1, if this joystick was expected to be in position 0, it's going to do something completely different on the controls. All right. And your robot's going to go in funky ways. The other element of joysticks is almost all joysticks have buttons on them. And so here are your buttons. One of the odd things about buttons, this is only applicable to software writers, is that there is a given number of buttons. This is different for each joystick. And in the software, they start at 1. As you programmers know, most things, when there's an array of them, start at 0. But their index of joysticks, of buttons, is actually button 1. So make sure that you always have the correct value of the buttons. Notice the axes are not that way. Look, here's axis 0 is the x-axis, but this is button 1. Right now I'm squeezing the trigger, so button 1 will do that. All right. The other thing that might be on a joystick that the FRC robotics software recognize is the point of view. Many joysticks, including the one I'm holding onto right now, have a hat control. It can only take on one of 9 values. It can either be centered, forward, to the right, in the middle of those two, and these are for programming. These take on values in degrees. So this is 45 degrees is what, if I read the point of view, it will now be reading 45 degrees. This will be 0. This will be 360, I think. Take a look, find out what it's pulling up. Those are all the controls of a joystick. So just summaries, you have to know which axes you're looking at, and they start at 0. You have to know which buttons there are, and you have a point of view. That's all the things for the Logic Extreme 3D. You can put it to wherever you want, but you better make sure that at the beginning of the competition, it's where you expected. Sometimes people like to use game controllers instead of joysticks. They'll still be referred to in the software and on the driver station as joysticks, but here I have an imitation Xbox 360 control. So it shows up as an Xbox 360 control. I'm going to click on it. Notice it has many axes. On the control itself, there are 2 buttons that each have an X and a Y axis. Once again, I'm pushing button 1 all the way forward, so my Y axis is at -1, 0. All the way back is +1. In order to make sure that the robot drives with the way drivers are expecting, that is inverted in the software, so everything works. It has 2 more axes, which are the trigger buttons. You might expect the triggers to be buttons, but they're not. They're axes. So if I'm using this, I can go halfway forward with a trigger value. In the years that I've been doing FRC robotics, Team 247 has never used that feature on a trigger. We have used it. We treat them as buttons, but for the programming team, that means you have to program them a little differently. You have to program for, instead of being on, off, and in this case, you can't get it to -1. This is 0, this is +1, and there is no minus values. But instead of saying on or off, we typically will say, less than about 0.1 and more than about 0.1, meaning if you're squeezing the trigger, it's on. The buttons are all over. You can see the buttons on a controller if you had them. There are a total of 8, and every place there's a button, that's how it shows up. Except there's a cross on most game controllers, including the Xbox one. That's the point of view. So that thing shows up this way. We often use it as a button, but one of the things that we do sometimes, sometimes we have if our elevator needs to go up or down, there's only 2 directions. So it might be, if you want that, you might take the elevator up. This, you might take the elevator down. But look what just happened. Now I'm not pointing straight up, but my thumb feels like it's pointing straight up. So usually if you're just doing this as an up-down control, the programmer should program it so that if it's anywhere in any of these positions, that means back. Any in these positions, that means forward. You've got to be a little bit careful if you're doing left and right with that, because, okay, is this forward or is this left? The programmers and the drive team have to work together to make sure the buttons do what they're expecting. Another cool element that Xbox controllers have and that some joystick has is rumble. Now, I can't make this happen, but in code, I can actually write code that will force the controller to vibrate. I can use that as I can use that to signal the operator about something that's happening. The last time we used this in competition, we had a danger zone on our robotic arm. You were never supposed to get above a certain area, otherwise we were in a penalty area. We were extending too far. So we would make it, as it got close, it would start rumbling, and that way we could verify that we were getting close to the danger zone and that they should back off and change the settings. So that's it for joysticks. Make sure that you know how to use them, how to plug them in, play around with a couple of different varieties so that you know this, so that you're not trying to learn this while you're in the pits getting ready for a competition. That's all for this video.